Hello everyone, welcome to Cloud Safari tutorials, and today we are going to learn about Amazon Sagemaker. Amazon Sagemaker is a machine learning service provided by AWS as a cloud provider, and it is already hosted in AWS environment. And from this machine learning service we can build, train, tune and deploy our machine learning models at scale. So, Amazon Sagemaker is like a magic tool for making smart machines. It helps us build, train, and use these machines to solve complex problems. With Sagemaker, you get a suite of tools and infrastructure that is designed to simplify the complex process of machine learning. You can use notebooks, debuggers, and pipelines all within one single integrated development environment. Plus, it's fully managed. It is managed by AWS, so we don't need to worry about the technical stuff. It takes care of all the complex parts like setting up servers or choosing the right tools. So why we use Sagemaker? It's all about the choice and the efficiency. Choose from a wide range of machine learning tools. We can deploy models with just a few clicks and manage everything in a user-friendly interface that is very easy to use actually. Plus, it also ensures high performance and cost effectiveness, making it accessible to anyone. It empowers every developer to innovate with machine learning, making complex problems simpler and more accessible actually. So guys, today we are diving into Amazon Sagemaker, a powerful platform that simplifies the process of building, training, tuning and deploying machine learning models. In this hands-on guide, we'll walk through the basics of setting up our simple model in Sagemaker. Before we dive into the hands-on, let's set the stage. All you'll need is an AWS account with access or permission to AWS Sagemaker, and you must have some basic understanding of machine learning concepts and a dataset, but for this time we are using dataset provided by AWS itself for learning purpose. And you also have to familiarize with Python programming and with Jupyter Notebook. So let's start it. So first thing first, log into your AWS account, and next we need to create a Sagemaker notebook instance. So search for the Sagemaker from the search bar. And this is where all the magic happens. Choose a notebook instance, so search for the notebook, and here is notebook instance. There are no any resources right now, so we are going to create a new notebook instance. Just give it a name. For notebook instance type, choose MLT2 medium. This is the least expensive instance type that notebook instance software, and it specifies for this exercise too. If MLT2 medium instance type isn't available in your current AWS region, choose the MLT3 medium or something else. So for platform identifier, choose a platform type to create the notebook instance on. This platform type dictates the operating system and the Jupyter Lab version that your notebook instance is created with. So for now I am using Amazon Linux 2 with Jupyter Lab 3. For IAM role, choose a create new role and then choose create role. This IAM role automatically gets permission to access any S3 bucket that has Sagemaker in the name. It gets this permission through the Amazon Sagemaker full access policy, which Sagemaker attached to the role. Our IAM role is attached successfully. Then click on create notebook instance. It takes some time to change the status from pending to in service. It may take 1 to 2 minutes. So going forward, to create a Jupyter notebook to start scripting for training and deploying our models, to create a Jupyter notebook in the Sagemaker notebook instance. Using this notebook, you can conduct machine learning experiments for training and inferencing while accessing the Sagemaker features and the AWS infrastructure. For our lab, we are going to use Jupyter Lab. So if you open the notebook in the Jupyter Lab view, on the file menu, choose new and choose notebook, and for kernel, Choose Conda Python 3. This pre-installed environment includes the default Anaconda installation and Python 3. So first of all, give it a name and save the notebook. So for next, we are going to download, explore and transform data in this notebook. So in this step, we are going to load the adult census dataset to our notebook instance using the SAP library, and we are also going to review the dataset, transform it and upload it to the Amazon S3. Actually, SAP is a game theoretic approach to explain the output of any machine learning model. So going to the lab, now I have already managed the code and we are going to use that, and I will definitely explain about the course. So first, we are going to load adult census dataset using SAP library. In this returns some of the features. To display the statistical overview of the dataset, we are using this script. Now we split the training set to separate out a validation set. The validation set is used to evaluate the performance of the trained model while tuning the model's hyperparameters, and 75% of the training set becomes the final training sets, and the rest of it is a validation set. Now we are using Panda library and a package to explicitly align each dataset by concatenating the numeric features with the true labels. Finally, we are going to train this dataset to check if the dataset is split and structured as expected. And then we validate the test and finally test it out. Now we convert the train in validation data frame objects to CSV files to match the input file format for the XGBoost algorithm. Using the Sagemaker in Boto 3, we are going to upload the training and validation datasets to the default Amazon S3 bucket. The datasets in the S3 bucket will be used by a compute optimized Sagemaker instance on the Amazon EC2 for training. So the following code sets up the default S3 bucket URI from our current Sagemaker session and creates a folder and uploads the training and validation datasets to the data subfolder. After successful creation of model, now we are going to train that model. To choose the right algorithm for our dataset, we typically need to evaluate different models to find the most suitable models to our data. For simplicity, the Sagemaker XGBoost algorithm, which is the built-in algorithm for this Sagemaker, we are using this throughout this tutorial. Next, to run a model training job, we are going to import Sagemaker Python SDK and start by retrieving the basic information from our current session of Sagemaker. So this returns the following information: region and a role, the current AWS region where the Sagemaker notebook instance is running, and the IAM role used by the notebook instance. Next, we are going to create an XGBoost estimator using the estimator class. It is the sample code, and to construct the Sagemaker estimator, we are using image URI to specify the training container image URI. And role, the AWS identity and access management IAM role that Sagemaker uses to perform tasks on our behalf. And the instance count and instance type, the type and number of Amazon EC2 ML compute instance to use for model training. For this training exercise, we are using single ML X large instance which has 4 CPUs and 16 GB of memory. Next, we set the hyperparameters for the XGBoost algorithms by calling the set hyperparameters method of the estimator. You can also tune the hyperparameters using the Sagemaker hyperparameter optimization feature. Next, we are going to use the training input class to configure a data input flow for training. The following code shows how to configure training inputs objects to use the training and validation dataset that we uploaded to Amazon S3 in the split the dataset into train, validation, and test dataset section. To start model training, we are going to call the estimator fit method with the training and validation dataset by setting wait true. The feed method displays progress logs and wait until training is complete. It takes some time to train the dataset. This training job might take up to 10 minutes. Now the training job has completed. Now we are going to specify the S3 bucket if the URI where the debugger training reports are generated and check if the report exists. Next, we are going to download the debugger XGBoost training and profiling reports to the current workspace. Now this script returns the file link of the debugger profiling report that shows summarizes and details of the EC2 instance resource utilization, system bottleneck detection results, and Python operation profiling results. Now we have trained XGBoost model. Sagemaker stores the model artifact in our S3 bucket. To find the location of the model artifact, we have to run this script. We got the location of the model artifact. So for next, we are going to deploy the model to Amazon EC2. To host a model through Amazon EC2 using Amazon Sagemaker, we have to deploy the model that we trained in create and run a training job by calling the deploy method of the XGB model estimator. When we call the deploy method, we must specify the number, type of instance that we want to use for hosting an endpoint. Here you can see here is initial instance count, the number of instance to deploy the model, and the next one is instance type. That is the type of instance that we want to operate our deployed model. And next, serializer. That serialized inputs data of various formats is numpy, array, list, file, or buffer to a CSV formatted string. We use this because the XGBoost algorithm accepts input files in CSV format only. So this deploy method creates a deployable model, configures the Sagemaker hosting services endpoint, and launches the endpoint to host the model. So we can see that our endpoint is in creating status, and when it is done, then it changes to in-service status. Now we have successfully trained and deployed a model using Amazon Sagemaker. Now we are going to evaluate the model to ensure that it generates accurate predictions on the new datasets. And for the model evaluation, we are going to use the test dataset that we created in the step of transform a dataset. To evaluate the model and use it in the production, we have to invoke the endpoints with the test datasets and check whether the inferences that we get returns a target accuracy that we want to achieve. So to evaluate the model, we have to set up the following functions to predict each line of the test set. In this code, the rows argument is to specify the numbers of lines to predict at a time. We can change the value of it to perform a batch inference that is fully utilize the instance hardware resource. Now, we are using this code to make predictions of the test dataset and plot a histogram that we need to take only the features column of the test dataset. The predicted values are float type. To determine true or false based on the float values, we need to set a cutoff value. So as shown in the following example of code, we use the scikit-learn library to return the output confusion matrix and classification report with a cutoff of 0.5. So to find the best cutoff with the given test set, compute the log loss function of the logistic regression. The log loss function is defined as the negative log likelihood of the logistic model that returns prediction probabilities for its ground truth levels. To find the best cutoff with the given test set, compute the log loss function of the logistic regression. The log loss function is defined as the negative log likelihood of a logistic model that returns prediction probabilities for its ground truth levels. So we are using this code, and the code numerically and iteratively calculates the log loss values where y is the true level and p is a probability estimate of the corresponding test sample. It returns a log loss versus cutoff graph. So now we are going to find the minimum points of the error curve using the numpy argmin and min functions. This returns log loss is minimized at a cutoff of 0.53 and the log loss value at the minimum is 4.34. Now we have trained, deployed and evaluated our first model in Sagemaker. Congratulations viewers on completing our video series on machine learning with Amazon Sagemaker. Remember to clean up after yourself in the AWS environment by deleting all the resources that we have created to avoid unnecessary costs. And in the comment section below, we'll provide links to the code and steps covered in the series, as well as additional resources that helps you to explore machine learning with Sagemaker further. So give the code and try and start your machine learning journey today. Stay tuned for more exciting content and happy machine learning.